Hello everyone and welcome to another AP Computer Science video. We're going to continue our discussion on inheritance in this video. We're going to finish up writing some classes and discuss an important concept in inheritance, which is the overriding of methods in subclasses. But before we do that, we should finish up our diagram. If you don't remember, we are designing the person class, or we have designed the person class that is an object through inheritance, and then we made a student class that is a person through inheritance, and a teacher, which is a person, and finally a grade lead, which is the one we're going to complete next, that is a teacher. So we can see any level of inheritance that we think is appropriate for our design to make that happen. And then we're going to discuss the powerful tool of overriding methods that makes this worthwhile. So let's finish this up real quick. Our teacher, we should do real quick before we move on to the grade lead, since teachers can have this advisory, this collection of students that are connected to them. They're homeroom students, I guess we could call them as well. We should make a simple method that, given a student, can add them to the advisory of a teacher. So let's go ahead and do that first. We'll say public void add advisee. And the input is a student object, and we'll call it STU for student. And our goal is to say, well, simply, if you're given a student, add them to your list of students. We're not going to put them in sorted order, by alphabetical order, or anything like that. We could, but for now, we're not going to be concerned with those kind of details. So we'll say advisory add STU. And we shouldn't be afraid that this is going to cause problems, because we know that one way or the other, whether they constructed it with the default or non-default, we do create a new empty list, so there's no chance of a null pointer exception occurring. So we'll stop here and we'll come back. Let's finish up this next class. We'll make a new class, and we will call this grade lead, capital L. And again, the goal here is to use inheritance, and so by default, a grade lead inherits from object, but we want to change that using the extends keyword, right? And so we're going to say teacher. And now we're going to say what makes a grade lead different from a teacher, because again, we wouldn't really make an extended class, a subclass, if we didn't have more data than that class already needs. So a teacher is one thing, but if we want to have a grade lead that is a teacher, it should have more information. So we'll say that a grade lead has a grade level that they are in charge of. So we'll say grade level, and this will be an int value. And then we'll say, well, on top of being a teacher that may or may not have an advisory, our grade leads also have a team of other teachers that work underneath them and do and help out, and so they all manage different grade level advisories. So for example, we might have a bunch of 9th grade teachers that work together to support the advisory system or the homeroom system that our school has. So we'll say private, and here's a good choice for an array list to collect our teachers, and we'll call it team. So this is the team of teachers that are involved with our grade lead. Now I'll fix imports so that we can have our array list implementation available to us. Again, our goal is, we're not required to, but pretty much it's a really good idea to always make a default, and at least a default constructor in our class. Even if one is given to us, we should kind of make our own. So we'll say public grade lead. And if we don't ask for any information for a grade lead, let's first explicitly, again, we have choices now. We can say, well, we could call the default teacher constructor, which we're doing right now because it is implicit by default, and that would call this constructor, which would set the age to 22 and say mathematics, computer science, and advisory. And that might be just enough, and that's acceptable. And in fact, I'm just going to be okay with that, and I don't need the explicit call otherwise. And I will also add our grade level to assume that it's 9th grade if we were first created as a lead, and then we can say that our team is a new empty array list. So this is very much like a teacher. So there's our list. Our non-default constructor, which is useful to make a grade lead, it's going to be very much like a teacher. We want a name, an age, the department they work in, and we'll also maybe want the grade level that they're covering. So we'll say string name, int age. We'll say string the department they're in, and then we'll say now the new information is the grade level, so we'll say GRD, and that'll be it. And so now, again, I could maybe use accessors if we needed them to fill these two in. I don't have an accessor for the department yet, but I could create one in the teacher class if I thought that was worthwhile. But instead, we will just simply use the non-default teacher constructor, which internally calls the non-default person constructor. So we're kind of just passing along the work, and it saves us, the deeper we go into our hierarchy, the less and less code we have to theoretically write to do a lot of the same things. So we'll say super, we'll pass in a name, an age, a department, and that's basically it. And so again, if I hold my mouse over this, we can see that the computer is aware that I'm referring to, when I say super, the parent class, which is teacher, right? A grade lead's super class is the teacher, so there it is, right? And then now that I've done this, I can simply remember the grade level as whatever grade they told me, which might not be 9th grade. And then similarly, we will still initialize our team to be an empty array list of teacher objects. And so there are constructors. And again, we're not going to go into all the details of what this is, but we'll add one more method similar to a teacher. If you're a grade lead, you have the ability to add teachers to your team. So let's make a method that does that. Public void, add team member. And we'll say this is a teacher. And I'll do a TCH. And again, just like with teachers, this is a very simple process. We can say team.add whatever teacher you give us and add them to the end of the list. Wherever that teacher happens to be, they get put in the end of our list. Now again, so far none of this seems particularly interesting, and if we go to our tester and create some of these objects like we started to do, that's fine, but there's still not really, the only benefit we've had, we saved a couple lines. By calling this, we're saving 3 lines, and then calling 2 lines and so on. So it's not spectacular, but we can definitely jump up and improve this. So the next thing we will discuss when it comes to all of these classes, we'll go back to person because this is where we're going to begin, is the idea that when it comes to the object class, which is where everyone inherits from by default, there are several methods that are brought along or inherited for us. And even though we don't necessarily touch them all, there's 2 that are interesting to discuss. One in particular is very important in terms of when we're printing stuff to the console. The other one is useful for comparing objects, which long term is great for sorting values that are non-primitive, so sorting objects. So if we want to sort persons or sort teachers by their names or whatever values we wanted to equate them by, or searching for items, right? Because again, without having to go into the internals, we could just say, are 2 things equal to what we're looking for? So is this the teacher I'm looking for? An equals method would be very convenient. So there are 2 methods we're going to discuss. The equals method that's given from the object class and the toString method. And the toString method is the one we're going to discuss first. It is a method that returns a string representation of whatever our object happens to be. The default toString implementation for objects is not very good, and we can prove it real quickly by going to our inheritance tester. We created a person. Let's try to print out this method. So every object automatically inherits this toString method. So person is an object through inheritance, and therefore P1 has a method called toString. Let's go ahead and try printing it out. So if I simply say P1.toString, and I try to run it, we'll see what the output looks like and see that it's not very helpful in terms of what it shows us. It's really not helpful at all. I mean, I guess, but not really. And so we'll see in a moment what it does for us, and then we will have the ability to fix it. So here it is. This is what it shows us. It says package name dot class and then an @ symbol and then what is actually a hexadecimal value, which I believe is the memory address of our object. But that's not helpful. Like, well, that doesn't tell me what the person is. It doesn't show me a name or an age. It would be nice to be able to see the name or the age. And so what we're going to do through our inheritance system is say, you know what, the parent version of toString that was given to us is not great. Let's fix it up. And so this idea is called overriding methods. To override a method means to re-implement and change your parent's version to your own. But one very nice benefit of overriding methods is that even though we're re-implementing the method, we're not actually destroying our parent's version. We're basically making a second version that we can call, and we can actually pick between the 2 in any particular class, and that's convenient for certain things, and we'll see in a moment how that can help us. So let's go to the person class and override the toString method. I'm going to go to the bottom of my code, and I'll mention now, in order to override a method, so we're going to say, we can override re-implement methods inherited from super classes, but well, actually, we won't say but, we'll say and, if necessary, refer to the original parent class version. So we'll see this in a moment, how this can be helpful. But one rule that we must follow, so I'll put this in a separate line, and we'll say, in order to to override a method, it must have the exact same signature. And remember, a method signature is the access modifier, the return type, the method name, and the parameter list. Nothing can be changed in order for it to be an override. If we change the access modifier to be less strict or more strict, it's not going to work. It's not an override. If we change the name of the method, it's not going to be the same method. If we change the parameters, it's not the same method. And what's nice is NetBeans and the compiler will often warn you, if it's, well, not the compiler, but NetBeans at least will tell us, hey, if you want to, we can put like a little marker here to let you know that you've changed or overridden this method. We'll see in this in a moment. So the toString method. ToString is inherited from object and should return a string of the object. Right? So here's the signature for the toString method. Public string toString. Notice public capital string return type, no capital toString lowercase t, capital S, no parameters. If you do not put it in this way, it is not an override. In fact, if I look at NetBeans, here it is. There's a little suggestion that says, hey, if you'd like, I can add this notation called @override. And I'll click it just for now. And it really doesn't change your code. It's a kind of documentation. It's kind of like a comment, but basically says, hey, this is a overridden version. We are changing the parent version. And then now NetBeans gives us this little green thing. It says, hey, we're changing a method that was given to you. Right? And so this is a kind of convenient thing to do. But we'll leave it here for now and see what happens. And let's go ahead and implement this to what we actually want. So for a person, I want to display a name and an age. But I'm not printing. It's a return. It has a string return, so I can't print it directly. I'm going to generate a string and then return that string. So I'll say something like string output is equal to, I'm going to say something like name, and then attach their name. And so I have access to the instance variable name. So name, and then a new line character, so it's underneath, and then we'll do output plus equals age, colon, and then add the age and add a new line character. So there it is. And then of course I need to return that string, right? If you think about it, the reason I add the ln's or the \ns is because as if I did prints with new line characters, but since I'm generating a string, I must manually place them inside. And so there's the toString. And now just by doing this, I'm going to go back to that tester and run it again. And let's see what we see. Just to remind you, the original output showed inheritance.person at some random value. Now let's run it and see what happens. And there it is. Name and age of the person. It's the same object. And notice we used the default constructor. We said our default name was Jane Doe and her age was 15. The idea is that we, whatever the data is inside the variables, that's what's done. And so I can prove this real quick. If we use the non-default constructor, so we said Jimbo Jones, and then we did 18, and I ran this, that's what would show up in our object. There it is, Jimbo Jones, age 18. So this is very nice and convenient. The toString method is great. So still, this is not really that big of a deal. It's not a benefit. We could have made a method that did that for us. Why would we want to inherit and override the method? That's the real question. And the answer is going to be when we move on to our next class. Let's go to a student. So let's have student override toString. In order to override, we must have the exact same signature. Public string toString. And now here's the question. When we override toString, which version are we actually overriding? Is it the object method version or the person version? And the answer is it's always the parent. And in this case, the parent is not object but person, and therefore we're changing the person version. But the person version is pretty good. It gives us two pieces of data, the name and the age. So why don't we have this version, the student version, call its parent version as part of the work? Right? The goal here is as lazy, intelligent programmers is to minimize the work we're doing. Why should I rewrite the printing of the name and the age when the parent already does it? So what we're going to do is we're going to say the same output, But instead of starting off with the name and the age manually by putting strings and concatenating them and so on, I'm just going to call the method from the parent. And I had mentioned before that this is where the difference between super dot and this dot is important. In this situation, we are not trying to call the method that we're implementing. We're trying to call the parent version. And how do we know? The super keyword. So, use super to call the parent version of the method. Right? So there it is. And so now that I have that, that should say name, and then colon, and the name, and then age, and then colon, the number. And now we can attach to this, we can say output plus equals, and we'll say grade level, and we'll attach the grade level and a new line character. And then we'll say output plus equals, and we'll say GPA, and we'll say GPA plus a new line character. And then we will return the output. So let's see what happens. So this is using the overridden version. Now we have to go to our tester, and let's make a student object. Say student S1 is equal to a new student, and let's go ahead and put in a student name. So we'll say and there's the name, and then we need to give them an age, so we'll do 17, and then I think we have to give them a grade level. If I don't remember, let's check. We have to give them a grade level, which will be, let's say, 11th grade, and there it is. And then the default GPA is assumed to be 4.0. And then let's go ahead and say, let's print out s1.toString. And remember, students are persons. But because they overrode the toString method, we'll use their version. And so let's prove that this is in fact the case. Run it. And there it is. There's the original person, which is the name and age. And there's the toString of the student. And notice something. The name and the age are in fact there, even though I didn't really code it directly. The idea is the parent version, the person version is called. So let's take it a step further. Let's do the same thing for our teacher. So now let's do this a little bit quicker so we can get through this and move on, but we'll make a toString for our teacher. We'll say public string toString. We'll say string output is equal to super.toString. So we're going to call the parent version. We're going to say output plus equals. And now this one's going to be a little more complicated because a teacher has a department, so who they work for. And we'll go ahead and do that. We'll say department. And we'll attach the department and a new line character. We'll be smart about this, and there it is. And now I have a list of advisees potentially. It might be 0 more characters. So let's do some work. Let's test something like this. We'll say, well, if we have no advisees, no homeroom students, because it's possible. Sometimes teachers aren't given advisories for whatever reason. They have other duties. So we can say, you know what? If there are no students, then let's just attach to our output no advisory. Right, so this we know that this person has no advisory. Otherwise, we can simply say, you know what? Now that we know we have at least one student, we should loop through all the students and print them out. This is really convenient because we can call the toString of each student within our list. So let's go ahead and say output plus equals, oops, and we'll say advisory. I'll do a /n, and I'll put a couple lines just so it looks nice. Another /n, and then we will say for every student called STU in our advisory. This is a great usage of an enhanced for loop because they're objects. I don't need indices. I care about the object itself. And now here's the nice, wonderful thing. I can say output plus equals the student.toString, and then we'll add the extra new line character. Oops, I didn't do that. And there it is. And then finally, once this is done, we will simply return output. So the toString of the teacher is more complex, and there it is. And let's see what happens. Let's make a teacher. T1 is a new teacher. And I'll just use the default constructor, which is going to give them the name Jane Doe, which is fine. And then we will call the toString on the teacher. So we'll say system.out, we'll say t1.toString. Let's go ahead and run this. And so there is our teacher, Jane Doe, age 22. She's a default to the mathematics and computer science department, and she has no advisory. Let's add a student to the advisory. So let's add the student S1, or Bobby Bobertson, to our teacher's advisory. So before we print out the teacher's advisory, let's say t1.addAdvisee S1, right? Because that's an object, and that's what we're adding. So now if we run it again, toString is flexible enough to print out nicely. So there it is, right? So there's our teacher's name, there's her age, there's her department, and there's her list of advisors. And notice it uses the toString of the other one. But now, recognize, this is not a super call, this is another objects call, so it's using the student version, and it knows it. This is the person version. And then the one we're implementing is the teacher version. And now, the final step is to implement toString for our grade lead. So here we go. This is the last one. We will say, same as always, if we're going to implement it, it must be the exact same signature. Public string toString. And we'll say, same thing as last time, we'll say, make an output string, and we'll say super.toString. So this is going to handle the teacher facets of this type of object, because a grade lead is a teacher, right, through inheritance. So this is going to handle the name, the age, the department, and the list of advisees if they have one. And that's very convenient. It's quite a bit of work. And all we have to do is add, well, what grade do you manage? And if you have a team of teachers, what are they? So let's try doing that. So let's go ahead and try doing that. We'll say, you know what? Same as before, we will print out, we'll say output plus equals, and we'll say grade managed. So which version are you managing? And we'll say grade level. Oops, I need to do plus \n. Let's copy this, and then we'll do the same thing. We'll say output plus equals. Oh no, so we have a list, so we have to make a decision. So same as before, we will ask if the team has no teachers involved, then we can just simply attach no grade team. And there it is. We need to do a /n. And else, then we can safely go through every teacher in our list of teachers. So in a team, so for every teacher in the team of teachers, which is our array list, and now we can simply say, you know what, attach the teacher's toString information. So teacher, which again may have its own sub loop for the advisory if it has one. So teach dot toString, and then plus the initial, the extra new line, and then simply we will return the output. Now I know maybe the line breaks will not be pretty, so it's kind of hard to read, but if we really want to, we could put some effort into it, design it in a nice fashion. But I think that could be very easy to do, I think, to manage. But let's go ahead and leave it like this for now. And now let's test this finally by creating a grade lead. We'll call it GL. Actually, GL is a terrible name. Let's call it G1 because the L looks like a 1. We'll say new grade lead. We'll assume the default name. Actually, our grade leads give them a different name. And then, of course, they need to know their age. I don't know. We're going to go ahead and put 30. And we're going to go ahead and say what their department is. And we'll say world languages. And we'll say, I think that's all we need to put. No, we have to also include what grade do they manage. So we'll say 9th grade. And there it is. And so there's our lead. And then let's go ahead and do one extra thing. Let's add the teacher, team 1, to our leads team. So we'll say add team member. We'll add team 1. And then now finally we can go ahead and I should probably, yeah, that's fine. It doesn't matter the order. And let's print out that grade lead. G1. So here we go. And there it is. And so if we take a look at this, the initial person and its toString, a student and their toString, a teacher that has an advisory of size 1, is their toString. And then finally, a grade lead toString, which is the name of the person, the department that they're in. They have no advisory. Oh, I should put a new line character after no advisory. That's definitely. And then the grade they manage, and then their teachers. So let's fix some things. Let's go real quick to here. First and foremost, we should put a new line on our student, on our teacher, no advisory. That's one thing. That's one fix. In our grade lead, before we print out the list, we should definitely print out, output plus equals, and we'll say grade, and we'll attach grade level, team. We'll put a new line, and then we'll put a bunch of bars and a new line. There it is. So let's see what this looks like. So if I run back our tester, there it is, a little bit better. So there's our grade lead, his name and age, his department. He has no advisory. He manages grade 9 team, and he has one teacher. That teacher has a name and an age, a department they're part of, and then they have their own advisory. Right? And so if there were more students in our advisory, they would show up underneath each other and so on. So, and again, it would be nice to maybe tab things in, nest stuff, but that's a little bit more complicated in our console. But either way, the idea to take away from this whole process is that methods that can be overridden to enhance them, and they can take advantage of the fact that their parent version is pretty good. The toString of the grade lead is almost complete just by using its parent version, and we only added a bit more. Similarly, the teacher's implementation of toString is basically the parents with a little bit more, and so on. And it kind of staggers up. The only time that we often just completely erase the implementation is the first class that inherits from object, which is person in this case, because we don't want to show the object class name. That's ugly. So here, notice we did not call super.toString. It was not necessary. We're erasing the implementation. I'll stop the video here. Our next video, we will discuss the final process and benefit of this. And again, this is definitely one huge one. We'll discuss another method that can be overridden, the equals method. And we'll talk about the idea of polymorphism, which we'll discuss as a powerful tool in programming and is the last discussion in our inheritance topic that we'll see. I'll see you in the next video.